Okay, we're going to talk about linear inequalities. So linear, that means a line is what it looks like in a graph. And inequality means that it's not necessarily equal to, it could be greater than, it could be less than, it could be equal to, greater than or equal to, or it could be less than or equal to. So those are the four different options for inequalities. Um, so where does it come up? For example, if we were looking at a television show and we said the number of viewers was at least greater than this, right? Or at least this. But it could be significantly higher on a given night, right? So as time goes on, the number of viewers of a television show might decrease over time. But on a given night, it might be more than, right? So these are possible solutions for any given night in this time frame. So we want to show that instead of marking all those points down as possible solutions, we just shade this area. And then we say this function for the number of viewers is a function of time, t. So we say maybe at the start, this was kind of the minimum number that was expected. We'll just call it, I don't know, 5,000. And then over time, it's kind of decreasing by, I don't know, say 10 every day. So this would have a slope of going down 10 every day, so reducing by the time, plus 5,000. Okay, so that's how I would write the function for a given graph. Now I said equal to, but it's not actually equal to, right? It could be equal to the line, but I expect it to also be values that could be greater than it. So instead of writing equal to, I write greater than or equal to. Okay? So let's go ahead and graph a few problems. How about f of x is less than or equal to 3x plus 2. So how would I graph that? Well, I do it the same way that I graph the line. So the first question I ask myself, is the line included, right? And it is also, so the function values are equal to the line. So that is also included, so yes. So I can draw the line as solid. And then, so let's just go ahead and graph the line. So intercept is 2, and the slope is 3x, so up 3 over 1. And it's going to be a solid line. If it was not actually included, where the line was, the function values had to be strictly less than, then I would draw it as dashed to say that line's not included. Now, it's all the values that are less than the line, so when I look at the line, the function values that are less than the line would go down. So I'm going to shade everything below. So what the line does is it cuts the plane into two parts. There's one side and the other, right? And then the values that make this true are all the values on one side or the other. So if I pick this point right here, 0, 0, I expect that it will be true. So the function value of 0, is it less than 3 times 0 plus 2, right? So this is 3 times 0 is 0, so is 0 less than 2? That's the question, right? And it is, so this is a true value. So since that is true, it means it's included. Anything that's on this side of the plane, if I picked a value over here, for example, how about probably negative 3, 2. So negative 3 for x and 2 for f of x. So when 2, is that less than or equal to 3 times negative 3 plus 2? 3 times negative 3 is negative 9 plus 2. So negative 9 plus 2 is negative 7. So is 2 less than or equal to negative 7? No, negative 7 is actually not greater than. It's less than, right? Because you do not want to be in debt by $7. You would rather have $2. So this is false. So you would find out that all the values over here would be false, and all the values over here would be true. So instead of writing all those points, we just shade this whole area. Okay. So there are 4 possibilities, right? We could have greater than, we could have strictly less than, we could have greater than or equal to, or less than or equal to. So when we graph these will be dashed lines, because they are not, that means the line is not included itself. It's not actually equal to the line. And these will be solid. So dashed and solid. And if your equation is of this form, y equals mx plus b, where the m is by itself and then you have this inequality symbol between them, then you can say the values are greater than the line. That's how you can say it is. The values are greater than the line, or the values are less than the line. So if it is in this order, you can say this is going to be shaded above. So it's going to be greater than the line. Here it's going to be shaded below. The values are less than the line. Okay, but if it's in another form, so let's say you got something like this. Okay, let's go ahead and graph that one. So what I want to do is solve it for y. So I'm going to move this 2x to the side by subtracting 2x from both sides. And then I get negative 3y is less than or equal to negative 2x plus 6. And then I'm going to divide through by negative 3. And I have to divide this whole side by negative 3. So negative 3 divided by negative 3. And I just divided by a negative, so something should go off in my head that, hey, I'm dividing by a negative, so I have to flip this inequality symbol. So it should go like that. And this is 1y. And then negative 2 divided by negative 3 is positive 2/3 x. And 6 divided by negative 3 is negative 2. So this is the equation of my inequality, or my inequality as a symbol. And now I'm ready to graph it. So first I say, is the line dashed or solid? The line is included, so it's going to be solid. And my y-intercept is negative 2, and my slope is positive 2/3, so I go up 2 over 3 to that point right there. And it's a solid line. And it's all the values that are greater than the line, so I would shade above. Now, a way to check your answer, it's important to check your answer, is pick a point to see if it makes this original statement true. Go back to the original statement. That's a good place to check. You don't have to check this final statement, but just pick something that makes this original statement true. So let's pick a point, and 0, 0 is usually a very good point to pick. You don't want to pick a point that's on the line, so if you happen to graph something and it went right through the origin, I would pick a different point. But this is a good point to pick since 0 times anything is 0. So I go 0 minus 0, is that less than 6? And it is, it's true. So I expect 0, 0 to be a point that's shaded. If I came up with something that was false, I would say, well, this whole half plane is not shaded, and the other half should be shaded. So let's just check one point that's over here. How about 3, negative 2? I expect this to be false. So 2 times 3 for x, and minus 3 times negative 2 for y. Is it less than or equal to 6? So this is 6. Negative times negative is positive, so it's plus 6. Is that less than 6? So is 12 less than 6? No, it's not, and I expected it to be false, so that is not included as expected.